Okay, good day viewers, thanks for watching. In our today's class, I want us to study projectile. Projectile. Now, what is projectile? I don't want to define projectile, but I want to explain projectile so that you can define it on your own. Some may say trajectory, some may say parabolic movement. I'm not opposing such definitions, but I want us to understand it to the core. You get? So
Yes.
now, what is projectile, if I may ask? And many of us have observed movements of an object as they are being thrown into the air. And we wonder what that is. Now, when an object is launched into the air and that object is allowed to move freely on its own before it reaches the ground level, it is called projectile. When an object is launched into the air and that object is allowed to move freely on its own before it returns to the ground level, it is called projectile. And examples of projectile: example one, a thrown javelin; two, a fired bullet; three, a kicked football; four, a thrown stone. For instance, you can never find a soldier or a policeman shooting gun like this. If anybody, any force or any security agent point gun directly, maybe should I say horizontal to you, just know that that person want to kill you. Is either you hands up, you surrender. No go dey argue. If they say stop there, stop. Except you carry something for body. You Africans we know now, na what they do juju. Except you have your G for body, in the sense that if they shoot, it will not enter. Then you can argue. But for me, apologies, sir. And where I am, what can I do? You get?
Yes.
But when a policeman or a soldier eh, points a gun vertically, or should I say in a diagonal way, it means they want to shoot harassing gun. It's not targeted at someone directly opposite to that person. You understand now? So we should use that analogy to know the difference between vertical components and horizontal components. And we have two components in projectile. One component is what? Vertical
Vertical
component.
component.
Vertical component. And that vertical component has it that you say x is equal to u sine theta.
Yes.
And second one is horizontal component. Horizontal component, which is you use y equal to u cos theta. Did you understand?
Yes.
Good. Now, I want us to learn how to derive formulas of projectile, starting out with maximum time. Maximum time. Now look up. Starting out with maximum time. Maximum time. In brackets, that is T mass.
Yes.
How do we derive this? How do we derive this? From first equation of motion. From equation one, which states that V is equal to U plus AT. Now, you know that our V here is equal to 0. Why? Because it's going up. Not just because it's going up, but our V here is equal to 0. Initial velocity. If you want to project something now, the final velocity will be what? 0. Do you understand that?
Yes.
If I
Yes.
should throw this thing up now, that application has recorded initial.
Yes.
And by the time it reaches into the air, that is final before it returns to the what? To ground level. Do you understand?
Yes.
So our V here is equal to 0. Do you get?
Yes.
So now, this is 0 is equal to U plus, because gravity is involved. Because gravity is involved. Do you understand now? So this A now we call it what? Minus G. We call it G. But in this case, it is minus g because we are going against the gravity. When you are going against gravity, your g is minus g. But when you are due to gravity, your g is positive g. Did you understand that?
Yes, sir.
So 0 is equal to u plus times minus will give us minus, then gt. Now when this u comes here, becomes minus u equal to becomes minus u equal to minus gt. So and this minus now minus u equals to minus gt. This will cancel out. You have u is equal to gt. Now you're going to make t subject of formula. So this becomes t is equal to u over g. But remember that we're talking about vertical component. Maximum time. The time it took us to do what? Project something. So we call this t is equal to u sine theta over g. D is formula for maximum time. You can decide to put t mass here or you just put ordinary t. Did you understand now? So this is maximum time. The next one is maximum is time of flight. Is what? Next one is time of flight. How do we get time of flight? Time of flight simply means 2 times t. That is twice
The the
the
time.
maximum time.
Okay.
The time it took an object to ascend to ascend at a height. So this is t is equal to 2 times u sine theta over g over 1.
Yes.
So don't forget that this t, eh, if that will mess with what you know, let me just explain it and then make it in a way you understand. Just stay with me and don't mind my duster. So now we say bet t is equal to u sine theta over g. Then we say therefore t is equal to 2 over 1 times u sine theta over g. So t now is equal to 2u sine theta over g. Do you get now?
Yes.
This is our time of flight. Now let's find maximum height. Let's find maximum height. To find our maximum height, we use fourth equation of motion. We say from equation 4, this is v square is equal to u square plus 2ax. This is x, so not 5.
Yes.
Recall that your v is equal to 0. Don't forget that. So this is 0 is equal to u square plus 2 into bracket minus g. Then distance, height. Do you get?
Yes.
So now, this u square will cause this equality side to become minus u
square. Minus u square.
minus u square equal to plus times minus will give us minus
Minus
2gh. This minus u square equal to minus 2gh. Minus will cancel out. We have u square is equal to 2gh. So over here, we are going to make h subject of formula. How? We say h is equal to u square over 2g. Is that correct?
Yes.
So we say h is equal to, if you go to tailor for measurement, will you lie down for that tailor to measure you? You will stand, even if you're a girl or you're a woman. For the fact that you have legs,
Yes.
your length will be measured to avoid wearing jump up or to assist that as you trek, it will sweep the floor or the street for the owners. So proper measurement must be taken. So that measurement, it is what? Vertical what? Component.
Components.
Do you understand? So
Yes.
height has to do with what? Vertical what? Component. Do you get that point now? So
Yes.
here we're going to use u sine theta all sphere over 2g because our u here has sphere. So this will be h is equal to u sphere sine sphere theta over 2g. This is their formula for maximum height. Do you get?
Yes.
Now let's find range. Range. Let's find range. Give me that marker. Give me that marker. Let's find range. To find range from equation 3, that is from third equation of motion, equation 3.
Yes.
We have x is equal to ut plus half at square. But a here is equal to 0. Why? Because range is a horizontal component, not a vertical component. So when you are introducing vertical component into horizontal component, that means that vertical component is useless there, it is 0.
Yes. I understand.
Do you get the point now?
Yes.
Just like introducing horizontal component into vertical component, that means horizontal component there is equal to what? 0.
Zero.
For instance, we all have been to airport before, right?
Yes.
I've not been to airport before, I'm not gonna lie. I have seen it in the movie. I've not been there, but one day I'll enter there.
Okay.
So now you observe plane as it run on its path before it launch itself into the air, right? At
Yes.
that point, at which at that point in which the plane dash itself into the air, is no longer range o. It has broken that horizontal barrier. So that horizontal A now is going against gravity now. It will apply energy and force due to the A.
Yes.
Do you understand now?
Yes.
But if a vehicle is moving on a path, for the fact that it's not going up, you are still on that range.
Yes.
So that is why I'm telling you that A here is equal to 0.
Agreed.
No due to gravity, no against gravity here. So, and if A here is equal to 0, that means here is S is equal to ut because everything here is equal to 0. It's just like plus 1 over 2 times 0 times t square, which means everything here is equal to 0. Do you understand? So we have S is equal to ut. Do you get the point now?
Yes.
But now there's a challenge here. The challenge here is that this t, but t here is time of flight. T here is time of flight. T here is time of flight. So whether you have small letter t or capital letter t, I want you to know that t here in range now, here is time of flight. So what do? You say x is equal to, our u here is horizontal component, which is u cos theta times our t here is what? U, not just u, 2u, because we say it's time of flight. 2u 2u sine theta over g. So this one now over 1. Did you understand now?
Yeah.
Now let me complete that here. I believe you've written this, right? Okay. So let me repeat what I have there over here. I had S is equal to U cos theta over 1 times 2U sin theta over G. Did you get the point now?
Yes.
So now S is equal to, we have U here. That is 2U square. Eh?
Yes.
Cos theta sin theta over G. Now we need to tell ourselves that this X now is range. Eh?
Yes.
So we say R is equal to 2U square cos theta sin theta over G. Eh? But but 2 cos theta sin theta is equal to sin 2 theta according to trigonometry.
Trigonometry. Yes.
Eh?
Yes.
According to what? Trigonometry.
Trigonometry ratio.
So what do we do here? We say R is equal to U square sin 2 theta over G. Eh?
Yes.
R is equal to U square sin 2 theta over G. This is our formula for maximum, sorry, for range.
Yes.
So mathematics found application in physics. That is why if you must be good at physics, you must be good at mathematics. Do you get?
Yes.
There's no two ways about it. If you want to be very good, want to be good, eh? Want to be good, you need to be good at mathematics, right?
Yes.
You want to be good at physics. So that is that on projectiles. See you in my next class.